one time with respect to x, again differentiating with respect to x, that is d by dx of d square y by dx square 1 power minus 5 by 2 into dqy by dx cube. We can differentiate this by using uv formula, uv dash plus vu dash. So here u value is d square y by dx square 1 power minus 5 by 2 and differentiating dqy by dx cube, that is d power 4y by dx power 4 and the constant to dqy by dx cube, and differentiating d square y by dx square whole power minus 5 by 2. This is minus 5 by 2 into d square y by dx square whole power minus 5 by 2 minus 1, that is minus 7 by 2 is equal to 0. So this can be written as d square y by dx square whole power minus 5 by 2 into d power 4y by dx power 4 is equal to 5 by 2 into dqy by dx cube into d square y by dx square whole power minus 7 by 2. So we can cross multiply, we'll get 2 into d square y by dx square whole power minus 5 by 2. This minus 7 by 2 comes to this side, that become plus 7 by 2. Minus 5 by 2 plus 7 by 2 is 1, and d power 4y by dx power 4 is equal to 5 times of dqy by dx cube. Okay, this is the differential equation. So we need to find order as well as degree. Order is equal to maximum derivative is 4 and degree maximum derivative power is 1. So order is equal to 4 and degree is equal to 1. And I am taking one problem from degree lecturers. The degree of the, this is from DL, the degree of the differential equation whose solution is y is equal to a into e power x plus b into sin x plus c into cos x. This is the equation relation. First we need to construct the differential equation, then we need to find the degree. Okay, already we know that order is equal to number of arbitrary constants. Here number of arbitrary constants are a, b, c, so order is equal to 3, no doubt. But we need to find a degree. So here the roots of the differential equation, here e power ax means 1 and here sin x plus cos x means plus or minus I. So the corresponding auxiliary equation is m minus 1 into m square plus 1, that is equal to 0. So the corresponding differential equation d minus 1 into d square plus 1 into y is equal to 0. Now multiply, we get to d cube plus d minus d square plus minus 1 into y is equal to 0. So the differential equation y triple dash plus y dash minus y double dash minus y is equal to 0. So here order is equal to 3, but we need to find a degree. Degree is the maximum power is the maximum power of highest derivative is 1, so degree is equal to 1. And I am taking another problem from Polytechnic lecturers PL. The solution of homogeneous initial value problem.
Sir, before problem, sir, excuse me, sir.
Yes, sir.
Sir, actually, before ఈ ప్రాబ్లం లో మనము మామూలుగా ఈ కాంప్లిమెంటరీ ఫంక్షన్స్ పర్టికులర్ ఇంటర్వ్యూ చేసేటప్పుడు అన్ని కూడా దాదాపు సెకండ్ డిగ్రీ అండ్ ఫస్ట్ ఆర్డర్ డిఫరెన్షియల్ ఈక్వేషన్ చేస్తాం కాబట్టి సింపుల్ గా ఫస్ట్ ఆర్డర్ అని ఫస్ట్ డిగ్రీ అని చెప్పేయచ్చు సార్.
ఓకే సార్, నో ప్రాబ్లం సార్, చెప్పొచ్చు డైరెక్ట్. ఓకేనా, క్లారిటీ కోసం నేను ఇచ్చాను.
థ్యాంక్ యూ సార్, థ్యాంక్ యూ.
ది సొల్యూషన్ ఆఫ్ homogeneous initial value problem initial value problem is y is equal to 2 into e to the power of 10x plus sine 3x. Then the least possible order of the differential equation is. Now actually this is the roots 2 and plus or minus 3i. So here m is equal to 1 comma plus or minus 3i. The corresponding auxiliary equation m minus 1 into m square plus 9 is equal to 0. So here when we multiply d minus 1 into d square plus 9 into y equal to 0, this is the corresponding differential equation, but we need to find a order of the differential equation. Order is equal to here d cube is there, so order is equal to 3. Okay, order is equal to 3. Now I am taking one important thing to remember here. If the differential equation of the form y is equal to e to the power of dy by dx, then here y is equal to, we can write it is the expansion of e power x, that is 1 plus x by 1 factorial, dy by dx by 1 factorial plus dy by dx whole square by 2 factorial plus and so on. So here in this case the order is defined, order is equal to 1, but degree is equal to degree. Here the derivative powers will be increased, so degree is not defined. Whereas if here it is the dependent variable, here order is defined, degree is not defined. If it is independent variable, if x is equal to e to the power of dy by dx, here in this case we can write dy by dx is equal to log x to the base e. Here in this case order is defined, that is 1, also degree, that is 1. Okay, order is equal to 1 and the degree is equal to 1. And I am taking another one is, if y is equal to sine dy by dx, that is y is the expansion of sine in terms of dy by dx, that is x minus x cube by 3 factorial, x power 5 by 5 factorial and so on. That is xc of dy by dx minus dy by dx whole cube by 3 factorial. Next term is dy by dx whole to the power of 5 by 5 factorial plus or minus and so on. Okay, here in this case also we can define order is equal to 1, but the degree is not defined, Okay, now if it is dependent variable, when it is y is the dependent variable, if we take in place of dependent variable I am taking x independent variable. If x is equal to sine dy by dx, then we can't write sine inverse x is equal to dy by dx, because sine is not invertible, since sine x or sine is not invertible in the whole interval, not invertible in the whole interval. So in the interval minus pi by 2 comma plus pi by 2, the sine is invertible. That means if we are given minus pi by 2 less than or equal to dy by dx less than or equal to plus pi by 2, here in this case we can write x is equal to sine dy by dx as dy by dx is equal to sine inverse x. Okay, here in this case we can define order and degree. Order is equal to 1, also degree is equal to 1. If the interval is not given, here in this case the degree is not defined. So from these examples, similarly we can we define the y equal to cos dy by dx, y is equal to log dy by dx, like that. The independent variable is there, we can talk about the degree, otherwise we can define only order. Now my question is the order of a differential equation is defined or not for any differential equation?
Always defined, sir.
The order of a differential equation, is always defined. What about degree?
Degree is not defined, sir, when trigonometric functions, logarithm functions, exponential functions contain the maximum derivatives.
Yes. So, but not degree. We can write, but not degree. Okay. The degree, the order of a differential equation is always defined, but not degree. Okay. These are the some bits, previous bits from competitive exams regarding order and degree of a differential equation. Okay.
Sine is not invertible. Please explain that.
Okay, sine x, if we in case y is equal to sine dy by dx, here in this case order is equal to 1 but not degree. Okay, degree is not defined. Okay, if we are given in place of y, we are given independent variable x. Here in this case we can't write like this. Sine inverse x is equal to dy by dx అని రాయడానికి వీల్లేదు, ఎందుకంటే sine is not invertible in the whole interval. Complete interval lo, అంటే complete real number system lo, it is not invertible. That's why, but the sine is invertible in the interval minus pi by 2. I am writing here sine x is invertible.
Invertible meaning ఏంటి sir?
Sine inverse exist కావడం అండి. It is 1 and on 2.
Okay.
Invertible in closed interval minus pi by 2 comma plus pi by 2. In this interval sin inverse exist అవుతుంది, అంటే sin inverse x is equal to రాసుకోవడం పాసిబిలిటీ అవుతుంది, బట్ ఇక్కడ ఇంటర్వెల్ మెన్షన్ చేయలేదు కాబట్టి sin inverse x రాసుకోలేదు. ఇక్కడ కండిషన్ ఇచ్చాడు అనుకోండి, minus pi by 2 dy less than or equal to dy by dx, it is closed interval minus pi by 2 and plus pi by 2, so we can write dy by dx as sin inverse x. Here in this case we can define the degree, that is 1. Order is also 1. Okay. Now I am taking, yes. Now I am taking another topic, that is linear differential equation. Linear differential equation. Now a differential equation is said to be linear in which the dependent variables and all its derivatives. Dependent variables. Okay. And all its derivatives. All its derivatives occur in first degree. These are in first degree only. First degree, and they are not multiplied together. They are not multiplied together. That means, for example, I am taking dependent variable is y. Y is must be in first degree. So its derivative, that is dy by dx, it is also in first degree, and they are not multiplied. That means y into dy by dx is not appeared. This condition is not worse. So then that type of differential equation is called a linear differential equation. Once again, a differential equation in which the dependent variables and all its derivatives occur in the first degree only. and no products of dependent variables and derivatives. Such type of differential equation is called a linear differential equation. I'm taking one example here. Okay, some examples. First example, I'm writing capital A. Okay. Now, you see the differential equation. dy by dx is equal to x plus sin x. Is it linear or not?
Sir,
Linear equation.
It is a linear differential equation. Linear differential equation of first order in general, first order. Okay. And I am taking another example B. d square x by dt square plus kx is equal to 0. Is it linear or not?
is second order linear differential.
Second order
Order తో
linear
మనకు పని లేదండి,
differential.
మనకు డిగ్రీ కావాలి, డిగ్రీ 1 ఉండాలి.
Yes, sir.
Okay, so it is a linear differential equation of second order. Second order. You can put your comments on chat box. You can please mute yourself. And third one, I am taking C. The differential equation y is equal to root x into dy by dx plus k divided by dy by dx. Now, is it linear differential equation or not?
Non-linear differential equation.
Here we can write this differential equation as y dy by dx. This is the product of dependent variable and derivative, and it is root x into dy by dx whole square. Here degree is equal to 2, so it is non-linear differential equation. Non-linear differential equation. I am taking another example. Call it as d square y by dx square whole square. D square y by dx square is equal to 1 plus dy by dx whole square whole to the power of 3 by 2. This is the differential equation. Now, is it linear or not?
Non-linear, sir.
Okay, it is non-linear differential equation, because we can write this differential equation as d square y by dx square whole square is equal to 1 plus dy by dx whole square. Here order is 2, so it is not a linear differential equation. That is non-linear. A differential equation which is not linear, that is called a linear differential equation. ఇక్కడ మీకు 4 బిట్స్ తీసుకున్నానండి. క్వశ్చన్ ఎట్లా అడిగాడంటే ఇక్కడే క్వశ్చన్ రాస్తున్నాను నేను. ది సెకండ్ ఆర్డర్ linear differential equation is అని మనకు ఈ 4 ఆప్షన్స్ ఇచ్చాడండి.
Option B.
Polytechnic lectures question. What is the right option here?
B.
Option B is the right option. Okay. Now I am taking, these are the examples for linear differential equation. Okay. Now we can write the second order linear differential equation. For example, the second order linear differential equation in the is of the form a0 of x into d square y by dx square plus a1 of x into dy by dx plus a2 of x into y is equal to b of x. Here a0 of x, a1 of x and a2 of x are the functions of x, may be constants, but not the functions of y. Okay, dependent variable functions kaakudadu, independent variable functions ka. This is the second order linear differential equation. Now, the nth order linear differential equation. The nth order linear differential equation is of the form a0 of x into d power n y by dx power n plus a1 of x into d power n minus 1 y by dx power n minus 1 plus and so on an minus 1 of x into dy by dx plus an of x into y is equal to b of x. Here also a0, a1, a2 up to an are the functions of x are constants, but not the functions of dependent variable. Now, my question is the degree of linear differential equation 1 or not?
Yes, sir. Degree is the always 1.
The linear differential equation degree is always 1. That means the question that the degree of every linear differential equation. Every linear differential equation is 1. Now, what about the converse? What about the converse? Converse, is it true? I'm
Not,
taking
sir.
an
Not, sir.
example.
Not,
Yes,
sir.
but not con. But
No.
not be but the converse
Need not to be true.
not be true or need not be true. Need not be true. For example, if we take one example here, I'm taking that is y into dy by dx is equal to root x into dy by dx, sorry, d square y by dx square plus k. Now, what is the order of this differential equation? 2.
Order is 1. Order 2. Degree is 1.
Order to
But not, it is not linear. Okay?
Linear because product of the dependent.
Dependent and derivative is here. So it is not a linear differential equation. This is the non-linear. So we can conclude that the degree of every linear differential equation is 1, but converse need not be true. Okay. Now I am taking next topic, formation of differential equation. Formation of differential equation. Okay, ఇక్కడ నుండి క్వశ్చన్ వస్తుందండి, important topic. Now, how to form a differential equation? If we are given a relation contains n arbitrary constants, so we need to differentiate that given relation with respect to x as n times. Okay, here n means number of arbitrary constants. After differentiation, we need to eliminate the arbitrary constants. Eliminate arbitrary constant. Then we get the differential equation. For example, I am taking one example, the differential equation of the family of parabolas. Y square is equal to 4ax is, okay, here the differential equation is y square is equal to 4ax and the arbitrary constant or parameter is a. So we need to differentiate this with respect to x as one time. So by differentiation we will get to 2y dash is equal to 4a. After differentiation, we need to eliminate the arbitrary constant, that is a. So from this we can write 2y dash is equal to 4a. 4a is equal to here y square by x. So here 2x into here 1y will be cancelled. So 2x into y dash is equal to y, or 2x y dash minus y is equal to 0. Y dash means dy by dx. This is the corresponding differential equation. Now I am taking another example. It is from DL degree lecturers. The differential equation of the differential equation of the family of curves. Family of curves. Ax square plus by square. Ax square plus by square is equal to 1, where a comma b are arbitrary constants. Where capital A, B are arbitrary constants. So here we have two arbitrary constants. So first of all, I am taking the different relation ax square plus by square is equal to 1, where a and b are arbitrary constant. So we need to differentiate this given equation with respect to x as 2 times. First time I am differentiating this with respect to x, we will get 2ax plus 2by into again differentiate y, we will get y dash, it is equal to 0. That is ax plus b into y dash is equal to 0. Okay, one time differentiation is completed. Before to this can be written as ax is equal to minus b into y dash. So we can write a by b or minus a by b is equal to y dash by x. Now again we can write this as for our calculator I am writing like this. Now again differentiate with respect to x. So we get u by v formula we can use here. That is x square x into again here uv method y into y double dash plus y dash into y dash. This is uv dash minus y into y dash, x differentiation is 1. That is equal to a by b differentiation is 0 constant. So here we have x into y double dash plus y dash square is equal to take outside y into y dash. This is the required differential equation. Now I am taking another example. It is from DL. It is also from DL. The differential equation corresponding to the family of curves. Y is equal to c into x minus c whole square is here, where c is an arbitrary constant. Where c is an arbitrary constant. Here we have only one arbitrary constant, but it is 2 times. Okay, it is a DL question. First, I am writing the relation y equal to c into x minus c whole square, where c is an arbitrary constant. We need to differentiate one time only. That is dy by dx is equal to 2c into x minus c. Again differentiate x minus c, will get a. So this is call it as equation number 1. Now you can squaring on both sides, will get to dy by dx whole square. That is equal to 4c square into x minus c whole square. So you can write this as 2c into c into x minus c whole square. So this is equal to I'm writing this as, this as 4c into, this is 4c into c square, 4c into c into x minus c whole square. So here 4c into c into x minus c whole square is nothing but y. This is equation number 1 and this is 2. So this is 4cy. Now we can write c value from this. Therefore c is equal to, we can write 1 by 4y into dy by dx whole square. This is the c value. And substitute in the equation number 2. So we get to dy by dx. Left side is in this equation, we are substituting dy by dx is equal to 2 into c value, that is 1 by 4y dy by dx whole square into x minus again c value, that is 1 by 4y dy by dx whole square. Okay. Now here 1 dy by dx will be cancelled and 2 side. So the left side is 2y, that is equal to dy by dx. 1 dy by dx is there, and here LCM 4y. So here we get 4xy minus dy by dx whole square. Here LCM 4y. Now by cross multiplication, we will get 8y square is equal to dy by dx into 4xy minus dy by dx whole square. Okay.
Pasha sir,
Yes, sir.
a small request.
Sir.